Hi everyone, and welcome to my first CFI teaching presentation. This lesson will be going over the different kinds of altimetry, or simply put it, the different kinds of altitude you would read on your altimeter. It's important to understand these different kinds of altimetry because it can help us determine what our performance can be. Say we're doing a high altitude job or a long line job, and it can also can help us determine how high above the ground we are, because that's basically what the altimeter is there for. That's what makes it one of our most important one of our most important gauges in the helicopter. And basically, in the short run, it's also going to be a question on your stage check. Okay, so in this lesson, we'll be going over our indicated altitude, our pressure altitude, density altitude, true altitude, and absolute altitude. So to start, indicated altitude is, we've all used it pretty much on every flight. When you're running up on the ground, as we've done dozens of times, you listen to the ATIS, and the tower gives you an altimeter setting. We'll say, for this example, 29.95. So you go to your Colesman window, and you set 29.95 as your altimeter setting. And for the most part, you use that for the rest of your flight without any changes, if at all. So that's what indicated altitude is. It's the most used as far as general flying, like what we do in our training flights, cross country, etc. The next altitude we have is pressure altitude. Pressure altitude, as I've drawn here, it's your height above the standard datum plane. Now, what the datum plane is, if you can see this red dashed line I've drawn here, I've borrowed this from one of CV's private presentations, is that it's just this kind of an imaginary line or a hypothetical line as to where the 29.92 pressure level is. And as you can see, it's constantly changing with location. So to kind of drive this aspect home, what I've drawn here is two helicopters, and as you can see, they're both pretty much at the same altitude over sea level. However, their pressure altitudes, one of them, the pressure altitude is lower over here, whereas the first one, the pressure altitude is higher. So two aircraft, the same height above sea level, and we have one with a higher pressure altitude. So if you were, during your flight, set your Colesman window to 29.92 and just leave it there the entire flight, this is what would happen. At this higher pressure level right here, it shows you have a higher altimeter setting, whereas same altitude, you haven't changed at all, but you're still at 29.92. Now you have a lower pressure. You have a lower standard datum plane, so it's going to show your altimeter having a lower altitude. So for the purpose of our flights, we don't want to always keep it on 29.92. It almost never will be 29.92 unless there are standard conditions at the airport. What we can use it for, however, is if we switch to 29.92 in our Colesman window, it allows us to determine what our pressure altitude is for the area we're flying in, and that'll help us in the next topic we're about to talk about, which is density altitude. Our next altitude is important for determining how our aircraft is going to perform on specific days. It's called our density altitude, and what it is pressure altitude corrected for non-standard temperature. And basically standards are 29.92, 15 degrees Celsius, but those conditions almost never exist. So basically, to determine aircraft performance, we can use either our POH or our E6B. So we'll say, just to make things easy, we'll say our temperature for today is 10 degrees Celsius and our pressure altitude is 4,000. So see past the video quality here. So I locate 10 degrees right here, and then I draw a line going up to 4,000. Now what I do is I move over to the side, and that number is my density altitude. So we'll say we came out to about about 4,250 density altitude, which is higher than our pressure altitude, so that means we're going to have a bit of reduced performance that day. So remember, a higher density altitude means less performance. A lower density altitude means we'll have more performance. And also, like I said, we can determine it through the E6B. You know, like you've seen right there, I've put my temperature 10 degrees above the 4,000 pressure altitude line, and right here I read my density altitude, which is showing approximately the same. As you notice, it's not as accurate as using the POH, but it's definitely a handy tool to use, say, for airplane pilots, you're mid-flight or you have a co-pilot figure it out for you, or if you're just out in the middle of nowhere and for some reason you don't have a POH and you want to find out what your density altitude is. Okay, next we have true altitude, which, as I've drawn out for you here, all it is your height above sea level. So as you can see, we have one helicopter over the mountains and the other one over the ocean. Now, the helicopter in the mountains, yes, its height above the ground is shorter, but that's not what we're measuring. We're measuring it from the mean sea level, where the ocean is, and just that line going out, and that's how high our mean sea level altitude, or our MSL altitude, is. So even though you see these helicopters are at the same level, even though this one has a short distance to the ground, their sea level altitudes are the same. Okay, and lastly we have absolute altitude. Now, just like I was talking before about true altitude, which is your height above sea level, this one actually is your height above where you currently are. Like say, for example, this aircraft is over sea level, is over the ocean. So its absolute altitude is greater, whereas this one, basically same flight level, is over the mountains. So its absolute altitude is less because its distance from the ground is shorter. That's all it is, just your distance from wherever you're at, the current ground that's below you. So somebody doing off airports in West Practice area will have a smaller absolute altitude than someone flying at the same flight level over Hillsborough. Okay, so just to review what we've gone over, indicated altitude the altitude going off the altimeter setting that the airport's given us. Pressure altitude, our height above the standard datum plane. Density altitude, which is pressure altitude corrected for non-standard temperature. True altitude, our altitude above mean sea level. And absolute altitude, which is the height above the current ground that we're flying over. Okay, well, I'll talk to you guys on the next lesson.